So following on from the previous video, we were trying to minimize the amount of material needed to produce this open top box for a given volume, for any given volume. And then we got to blah blah blah. We got to this stage here, where when x is big, it wants to do the positive quadratic. When x is small, it wants to do the reciprocal. So overall, our graph will look something like this. Okay. So now we need to find the minimum a. Well, to find out the minimum a, we need to differentiate this. So now we've got to differentiate this. Okay. So starting with a equals this, we differentiate it. It will give you this. When you come to differentiate this here, ingrain this inside your mind. Okay. You must memorize this. When you differentiate this, it becomes this. So when you differentiate this here, it becomes minus 4v, okay, and then the power here gets minus by 1. Okay. Well, anyway, you must ingrain this in your mind. It will save you a lot of time. If you forget, then rewrite this thing here as 4v times x to the power of minus 1 here. So when you differentiate it, this one gets multiplied down here. Hang on. When you come to differentiate this here, this gets multiplied down here. That will then give you minus 4v, and then the power itself gets, well, blah blah blah. Try to remember this. Okay, it will save you a lot of time. Okay, well, from here, differentiate it. It will then give you this. Okay, and then find out. Well, we want to know when the gradient will be 0. So we got to set this to be 0. Okay, so now set the a by dx equals 0. So that will then give you this. Blah blah blah. X equals blah blah blah. Add this to both sides. That will then give you this. And then times x squared to both sides. That will then give you this. And then divide both sides by 2. That will then give you this. And then divide. And then what? Let me think. Sorry. Yeah. And then cube root both sides. That will then give you this. So x equals this. You see, for a given volume, for any given volume, so that means you know v. V is fixed once a problem has been set. So you can work out your x. Okay, so for given v, for any given v, you can work out x. That would then, whatever this value here is, it will be the minimum amount of material needed to produce your box here. Okay, so now we need to know y. So pretty much, if you look at our box here, hang on, we are currently here. Okay, if you look at the box, hang on. Where's the box? Bear with me. If you look at the box here, we are varying x. So when you vary x, y automatically reacts to your x. So when you make x small, then y will automatically adjust itself to be taller because of this constraint here. Okay, because of this constraint here. So when you vary x here, y will just react to your x. So as you vary x, y will automatically react accordingly. So once you figured out x, then you pretty much got your y. Hang on, let's go back to where we were earlier. Hang on, earlier, where there? Go back to where we were. So earlier we were here. Okay, earlier we were here. So once you've got your x here, you can pretty much automatically find your y. So originally v was given by this. So once you've got your, well, rearrange this to make y the subject. So divide both sides, blah blah. That will then give you this. So all you need to do now to find out your y, all you need to do is put this into your x here. Okay, so you got to. So this here, at the moment, this is x, but then we've got to square it. But this is quite complicated when you square this. What does it mean to square this? So rewrite this thing here as this. Okay, so x is this. Rewrite this thing here as, rewrite the cube root as to the power of 1 over 3. Okay, so when you come to square it, because later on you've got to put this into here, meaning that you've got to square it. When you come to square it, once it's in this form, it's nice and easy. When you square it, this gets multiplied with this. That will then give you this. Okay, sorry, this here should be x squared. Okay, well anyway, x squared equals that. So hang on. So this here is x squared here. Okay, so y is given by this here. Okay, y is given by this. So what this means is, hang on, but let's tidy up this thing here. We can tidy this up. We can leave it as this, but let's tidy it up. So here visualize, hang on. So here visualize this as v to the power of 1, okay, times this thing here, and then because it's at the, well, yeah, visualize this thing here as this. Okay, so now this gets multiplied with, well, blah blah blah, from our section on indices. That will then take you to here, and then you can merge these two together. Okay, so this is like saying, well, when you merge these two together, it's like saying, get this, add this. So that's 3 over 3, add this. So add minus 2 over 3. That will then give you 1 over 3. And blah, blah, tidy up. You can tidy up, and it will come to this. Okay? So what that means is that for given volume, for any given volume, the height, the y here will be given by this, and the x here will be given by this for any given volume. Okay? We will continue in the next video.